Thank you.
Thanks, man.
Hello,
man.
everyone. Thanks for joining our session, proactively addressing customer concern with generative AI and Apache Kafka. I'm excited to have you here and share you some of the valuable insight on how you can take your data processing and analytics to the next level with powerful AWS services. My name is Saim. I'm a streaming SA at AWS. I also have my colleague Avaya joining with me in this session. By the way, this is a 400 level session, so we expect you have the basic understanding of Kafka and Flink. So in today's session, we will discuss about how you can use Kafka and Flink's real-time data capability or analytics data processing capability to get deep insight on customer interaction and derive proactive action. We will also explore how generative AI can help to get additional capability in our data processing pipeline. We will show you a real-world use case and a demo in this session as well. So companies today have massive amount of data coming from all different sources. And the challenge is figuring out how to actually make a sense of it all together. And that's where tools like foundation model can be really game-changing. So let's take a hypothetical scenario where an airline company want to proactively serve their customer based on their need. They want to analyze customer booking data, weather data, and flight cancellation data, and proactively offer an alternate travel plan to their customer. Now, if you see the use case I mentioned earlier, that company have few core requirements, like real-time view of customer data across all the system company have. And then context-based proactive engagement with the customer for better serving customer. And as you know, these days data is coming from all different sources. So in the demo today, we will utilize Apache Kafka and Flink to capture all those data sources in a centralized system. And with the integration with foundation model, we can take our data processing to the next level, where we can mix our business data with the foundation model powered by generative AI and get better and proactive response to our customer. And to build the end-to-end pipeline today, we will also use some other AWS services. For example, Amazon DynamoDB, AWS Lambda, and so on. And mostly we will write our code in Python and Flink SQL. So especially we're going to use Python for Kafka admin operation, creating Kafka topic, and Flink SQL for real-time data processing from our Kafka topic. So as I mentioned earlier, we will utilize the power of generative AI and foundation model. So let's take a step back and understand a bit more about generative AI and foundation model. As you know, the foundation model are pre-trained on vast amount of publicly available data. And these models are good at doing certain things. For example, summarization, classification, new content creation, and even generating high-quality visual. Popular model like Amazon Titan, Claude, Stable Diffusion, and so on. And generative AI is a type of artificial intelligence technology which helps generating new content. It's like a conversational way talking with a machine, the way we humans interact with each other. For example, you can ask generative AI to identify whether a customer business has been impacted due to a flight delay. However, this foundation model has been trained on a vast amount of publicly available data, and it has no clue about your business data. And there are few techniques you can follow to make generative AI response more accurate and relevant to your business. You can customize the base model, or either you can follow a different technique called RAG, which is a method to retrieve information from your business data and augment the generative AI model response. And Amazon Bedrock is a fully managed service to utilize foundation model securely and easily calling AWS API. You can customize base foundation model Or you can also apply a RAG technique very easily and quickly with a feature in Amazon Bedrock called knowledge bases for Amazon Bedrock, which help you from data ingestion to retrieval to prompt augmentation. So we will use Amazon Bedrock knowledge base as well. Now, it is important to understand that no matter how powerful this generative AI technology is, it is impossible to get the full potential of generative AI without integrating with your business data. And that's where tools like Apache Kafka can help. As you know, Apache Kafka is a popular open source distributed messaging system. And we offer a fully managed service called Amazon Managed Streaming for Apache Kafka or Amazon MSK. I want to take a bit of time to discuss how Apache Kafka fits into the use case we are discussing today, and you might find it relevant to your use case too. So Apache Kafka provides capability to capture or collect data from different sources, including file system, object store, relational databases, and so on. As you know, there is a popular tool in Kafka ecosystem called Kafka Connect. So with that, you can collect all those data from diverse systems and then push it to your Kafka topic running in Amazon MSK, where you get unlimited, virtually unlimited storage. So once the data is landed to your Kafka topic, now you can do low latency machine learning model inference, for example, identifying a scam or fraud, and even using the same data for model training as well. Not only that, you can then use those data to enrich your vector database for implementing RAG workflow. And another tool we are using in our demo today is Apache Flink. As you know, Apache Flink is a open source framework and a distributed processing engine, and we offer a fully managed service called Amazon Managed Service for Apache Flink. So Flink helps you to implement a closed loop system where generated content and the user feedback can be continuously monitored. So you can improve the generative AI model performance in real time as well. And you can do low latency data processing. Also, Flink can help you to provide a context before you call a foundation model, where you can do stateful data processing in Flink. And that helps to get a correct and the complete response from your foundation model. Now, before I show you the demo today in our session, I want to talk one more concept, which is prompt engineering. So as you know, with generative AI, you interact with machine in a conversational approach. And that conversation we call prompt. A simple prompt could be, is the customer providing a negative or positive feedback? But sometimes this simple prompt will not help you to get the correct answer that you're looking for. But if you provide a bit more context to what you're looking for, you might get correct response, as you see in this example, where I'm asking the generative AI to categorize it with a specific category that I'm looking into, like thank you, escalator, do nothing. And we will utilize this technique in our demo too. So here's the high-level end-to-end architecture looks like what we are building today to serve our customer proactively, where we have data coming from diverse sources in real time, and then we're using a streaming storage for low latency data ingestion, and also using this for low latency data processing as well, where we can have multiple consumer reading the same data without impacting in each other. And then we're using a stream processor, which help us to do stateful data processing, where we can call generative AI with a bit of context or providing the state that's required so we get a correct response. And that stream processor can also help us to enrich our vector database like Amazon OpenSearch so we can implement a RAG workflow. Not only that, with this stream processor, we can generate alert, enriching our dashboard and also our database. So with that, now I'm going to hand over to Avaya to show you the demo in our session today.
Thanks, buddy. Hi, everyone. So my name is Abe, and the second section of this talk, we're going to dive into a demo. But before I do that, I want to walk you through the high-level view of the data flow for the architecture that we'll be looking at. Now, the first piece of the architecture is going to be looking at Amazon Managed Streaming Service for Apache Kafka. Now, we've got 4 topics in Kafka. We've got customers, customer bookings, cancellations, so these are airline cancellations, and available flights. Now, the consumer for these topics is going to be Amazon Managed Service for Apache Flink. And we're going to use Flink SQL to consume those with a Kafka connector. Now, the first job for Flink is going to be processing cancellations. So as airlines cancel flights, we want to be proactive for our customers. So we want to be able to grab their available flight options, the cancellation details, and customer preferences. We're going to send that to Bedrock. We're going to build out a notification, and we're going to put that into another topic, which is cancellations reach out. That's going to be consumed by Lambda, and we'll see that in DynamoDB towards the end. The second part is looking at the cancellation analysis. So internally, we want to understand which airlines are reliable or less so reliable. And so based on that, we're going to look at how many cancellations are there for every airline, and aggregate that data, send that off to Amazon S3. And over in S3, that's going to be connected to knowledge base for Amazon Bedrock, which is going to enable us to consume that data and enrich the context for our foundation model in Amazon Bedrock. So don't worry if you didn't get that all. We're going to dive into the details now and step through all these pieces in the demo. So we start off in Management Console. Let's head over to Amazon Managed Flink. Now in Flink, we're going to spend the bulk of our time in Studio Notebooks. Now Studio Notebooks is hosted with Apache Zeppelin notebooks, and we're using the Flink processing engine. These are essentially serverless notebooks. So with the serverless notebooks, we get monitoring, CloudWatch monitoring metrics out of the box. So we can see our CPU, our memory, our garbage collection for our Studio Notebook, as well as the Flink processing engine. And if we head over to the configuration tab, we can also see the scaling. We can control the scaling for this notebook. We can look at the logging and monitoring and the networking configuration. If we want to deploy this notebook that we're going to walk through as a Flink application, we can also configure an S3 bucket here. And the last thing is supported connectors. So with Studio Notebooks, out of the box, you get bundled with 3 connectors. That is Flink SQL for Kafka, Kinesis, and IAM authentication. And so we'll be connecting to our MSK cluster using IAM authentication here. Makes it a bit easier to control the authentication with IAM policies. So let's head over to our notebook in Apache Zeppelin. So there's a few sections to this notebook. We're going to skip over a couple that aren't so important, like data prep, but let's take a look at the initial setup. So in the initial setup, we're going to first set off the region. We're going to set up our S3 bucket and where the MSK cluster is, and also install our dependencies. Next, we're going to set a few Flink configuration options. So the first one is execution checkpoint interval. Now this is the interval at which Flink will take a snapshot of the state of the streaming application and store that for a checkpoint for fault tolerance purposes. So if the higher interval means less regular checkpoints, which means more chance of data loss. Now the second configuration option is execution checkpointing mode. Now there's 3 options for that. So there's none, where you're disabling checkpointing. There's exactly once, which is what we're going to use here, which essentially means each record is going to be processed exactly once in the state of the streaming application. And there's also at least once, where records can be processed at least once. So there's 3 options. We're going to set up those configuration options, and then we're going to take a look at connecting to the MSK cluster. So we're going to set up our admin client and our producer, and once again, we're using IAM authentication to sync up with that MSK cluster. And the last piece of it is just a helper function to create Kafka topics. So we're just using the Kafka admin API to provision those Kafka topics. So we'll use that next. So if we collapse this section, we'll skip over the data prep, nothing really interesting in that, and we'll create our Kafka topics. So you probably remember from the slide, we've got 4 incoming topics. We've got customers, we've got customer bookings, airline cancellations, and available flights. So those are our 4 incoming data topics, and we're going to be writing out to cancellation reach outs. So we'll see that towards the end of this notebook. So we're going to provision those Kafka topics, We'll collapse that. We can skip over the seed Kafka topics. That's just putting the data into the Kafka topics. Let's take a look at that create manage table section. So this is where we're basically going to use Flink SQL to provision and be able to sync in with those Kafka topics. So we're going to create, this looks like standard SQL, but essentially we're creating a table that's going to, it looks like a standard SQL table. We're going to define the schema of the customer data, and we're going to, the metadata is probably the more interesting piece. We've got a connector we're using for Kafka. We're syncing in with the customer topic, and that's the location for the MSK cluster. So essentially, when we interact with this table, we're going to be interfacing with that Kafka topic. Now, this is just a bunch of Kafka tables we're going to define, so I'm not going to go through all of them, but the last one's the unique one, where we're leveraging a file system connector. Now, this is how we're going to write out to our S3 bucket, and we'll see that in use case 2 towards the end, so that's cancellation analysis. So now that we've got our managed tables in Flink, let's actually test to see if they work. So we'll do a super simple example of select star from customer. So what we're hoping is, this is using the Flink SQL interpreter, but essentially what we're hoping is the managed table that we created is able to show us the schema that we defined, is able to leverage the Kafka connector that is going to go off to the MSK cluster that we defined and pull data from that topic. So if we run this job, hopefully we're going to see the schema. Yep, so we've got customer ID, name, email, so the schema is recognized, the metadata for the table is recognized. And so now the scheduler is going to try and provision the Flink job. And so while we're waiting for that to run, let's jump over to the Flink dashboard. So we're just going to introduce the Flink dashboard quickly here. So the Flink dashboard enables you to see running stats of the Flink jobs that you've got going on in the Flink engine. So you can see things like latency, throughput, resource utilization, checkpointing statistics, essentially things to enable you to monitor and the health of your Flink application. So if you need to debug or troubleshoot your Flink application that's running, you would probably jump into this console. So we're not going to spend much time here. Hopefully we've got data coming back. We see we've got data received. So let's switch over to the notebook. And we've got data that's pulled from the Kafka topic. So essentially we know that our Kafka table, using the Kafka connector, is pulling data from MSK and reading from the customer topic. So let's collapse that section. Next, what we want to do is figure out how can we pull generative AI into this. So we want to use Amazon Bedrock. So we want to be able to call an external API. So to call Amazon Bedrock from Flink SQL, we're going to leverage Python UDFs. So user-defined functions enable us to essentially leverage the vast amount of Python libraries in Flink SQL. So what we can do is work with the Python library AWS SDK or Boto 3. We can pull that in and create a function which calls Amazon Bedrock. So what we're going to do here is we're going to define a scalar function. So we're going to define a bunch of inputs. We're going to pass parameters in, and we're going to get the response from Bedrock, and we're going to return that from the function. So looking at the function definition, the first parameter for the function is model ID. So we're essentially going to define, we're going to ask which foundational model do you want to work with. So we'll define that soon. And the rest of those parameters are basically information that we want to inject into the prompt. So customer preferences, the cancellation details, other flights that are available for this customer. We're going to build out this big prompt, which we're going to send to the foundation model. We're going to inject the parameters that we've gotten, we've had passed into this prompt. So things like available flights, preferences, and cancellation. And then we're going to build out a request. So this request is dependent on the model ID that we are going to use. So we're going to leverage Claude 3 in this example. So we're going to build out that request. We're going to invoke Bedrock with that request. And then we're going to grab the response and return that from the function. Nothing too complex. The last two lines on this are basically registering the UDF and then registering that UDF with the Flink environment. So Flink SQL can leverage it. Just sounds good in theory, right? So if we collapse this section, let's actually see if this works. So opening up, we're going to run some simple Flink SQL. We're just going to go select the UDF function. we're going to give it a model ID, and we're going to pass it some dummy parameters. So select UDF cancellation. The first parameter is our model ID. So we're going to leverage Anthropic Claude 3 Haiku model. And we're going to just pass it some dummy parameters. We just want to see if this works. So once again, those dummy parameters will be injected into the prompt, and that's going to be passed, well, hopefully when we run this, it's going to actually, the scheduler is going to provision a job. That job's going to execute that UDF Python UDF function. That's going to call Amazon Bedrock. We're going to build out that response, get that response back. We're going to return that, and hopefully we'll see that in this notebook. So there's a few layers here, but if we run that, and I think in this recording we've fast forwarded slightly, we get a response. So we can see, dear customer, I hope this email finds you well. I'm writing to you in regards to a cancellation of B due to C. So I'm not going to read through the whole prompt, but we can see that we are calling Bedrock, we're using the Claude 3 model, and we're getting some sort of response. Good. So we've got a lot of our building blocks to build out and solve our use cases here. So let's start looking at our actual use cases. So the first one was manage flight cancellations. So as a traveler, I'm on a big journey, and I realize that one of my flights in my link gets canceled. And so now I've got to figure out, that's super stressful. You've got to figure out who do I call, in what time zone, what are my flight options, how much it's going to cost. So the aim of this is we're going to, as an airline travel agency, we're going to receive these airline cancellations. We're going to look at the available flights. We're going to grab the customer's preferences and the cancellation region, and we're going to pull this together. We're going to pass it to our Python UDF, which is in the select statement. We're going to call Bedrock. We're going to, with the Claude 3 Haiku model, we're going to ask it to generate a message with all that data injected into the prompt. We're going to bring that back, and then we're going to insert that into the cancellation reach out table. And so that table is going to insert into the Kafka topic, our first outgoing topic. So fairly straightforward SQL statement, but essentially it's going to be calling out for each cancellation that comes through, building out a custom message for each cancellation. So we've kicked off that job. The second one is cancellation analysis. And so what we're looking at here is we want to count how many cancellations are there for every airline to figure out which ones are more reliable and less reliable, so we can help our customers with their expectations. So here, what we're going to do is we're going to build out a tumbling window, a 5-minute tumbling window for this demo purpose, but it might be longer if you build this out in production. We're going to count how many cancellations there are, group by airlines, and essentially insert this into cancellation analysis table. And now this table, if you remember, was the last unique one that we saw, and that's going to write it out to S3 bucket. Now, when we write it out to the S3 bucket, that's going to be linked to our knowledge base in Bedrock. So when we send a prompt to Bedrock, the foundation model will have that data available to it. So we've run those two use cases. Let's kick off the streaming of the flight cancellations. So once we run that job, cancellations are going to start streaming through. These jobs are going to start picking up these cancellations and doing their work. Now in this recording, we've fast forwarded it slightly, just so we've got a few examples and data. I'm going to jump over to DynamoDB. Now, if you remember, as we're inserting into this Kafka topic, we've got a Lambda picking up those messages, and then we've got a Lambda inserting it into DynamoDB. So our DynamoDB table should be full of customer reach out messages, responses generated by Claude 3 Haiku model from Bedrock. So let's take a look at the table. Let's go to the first one. And looks like we've got a message. So it basically says, Dear Lisa James, I'm writing to you in regards to a cancellation of a flight at a certain time. It gives two options in terms of these are alternate flights. It also says, hey, we've detected that these flights aren't on the same day, so we're also going to book you accommodation near the airport. So it's basically trying to support the customer and making sure that, hey, we're there for them. There's a cancellation, but we can still streamline the experience. So we've got a message. That's good. So this message will go to our customer reps, and essentially our customer reps can then communicate to the customer as needed. That's our first use case. Let's take a look at a second use case, which was cancellation analysis, where we had 5-minute tumbling windows writing out to an S3 bucket. Now, if we head over to S3 bucket, we had cancellations summarized and grouped by airlines, and they were written out every 5 minutes. So if we head over into the analysis folder and sort it by last modified, we can see that, hopefully you can see that, a file is written out every 5 minutes. So we'll look at the details of that in a moment, but let's jump over to Bedrock Knowledge Base. So Bedrock Knowledge Base is a new capability within Bedrock which enables us to enrich the context of a foundation model with our own data. So in this case, cancellation data. So as data is being written into S3, Knowledge Base is able to synchronize that, embed vectors and store that in OpenSearch. And so when we call or send a prompt to our foundation model, it's able to leverage and bring in that data as needed. So based on that, we can test this model out. So if we click on our knowledge base and click on test knowledge base, let's select a model. Let's go with Claude 3 Sonnet and give it a super simple prompt. Give me a one-line summary of the cancellations of the most and least cancelled airlines for the 31st of March at 2:30 a.m. Hopefully you can read that, but it's come back with at 2:30 a.m. on the 31st of March, Global Air has had 8,500 cancellations, whereas Moonlift had 4,500 cancellations. If we click on the source details, we can actually see the data pulled from S3 to build out that response. And so if we actually check with the raw data, the numbers actually match up. So what this enables us to do is leverage our real-time streaming data through our system and be able to leverage that data to enrich the context of our foundation models when we need to. So, generative AI is transforming the way we interact with streaming data. We are able to adapt, we're able to predict better, and we're able to derive insights faster. So with machine learning, you can detect patterns and recognize intent, and with generative AI, you can actually generate summaries and action plans that we can consume. So with Apache Kafka and Flink, it provides capabilities to enrich the context with the latest data. So we saw in use case 2, we can actually send all that data off to S3 in our knowledge base, so that's available for our foundation models to leverage. Cost and latency are still important considerations. We understand these large language models can be quite sizable, consume a lot of compute, and at times inference can take a couple of seconds, which isn't ideal for inference purposes or real-time streaming data. So there's a few patterns you can use to manage this. So one is categorization of events. You can be selective on which sort of events you trigger. You can leverage aggregation like we saw in use case 1, or you can enrich a knowledge base. So the foundation models can pull in the right data that it needs to at the right time. Now we've been through a lot super fast, went quite deep, but if you want to learn more about MSK and Kafka or Flink, check out the first 2 QR codes, Bedrock for the third, but if you want to play with the demo and the code that we showed you, we've also got the workshop available. Skill Builder, if you want to learn from AWS experts, please do check it out. And thank you very much for your time. Hope you got something valuable out of this.
Wow. That was impressive. What a session, eh? Thank you so much for sitting through this. I know you've been through a lot of sessions today, so really, really appreciate you being here. If you could please rate the session, make sure that you get onto the AWS Summit app to rate the session. And thanks again to our 2 speakers in Abs and Siam. They did a fantastic job. Thank you for being here.